In this video, we will do problems from exercise 6.6. Question number 1. Find a parametric form of a vector equation of a plane which is at a distance of 7 units from the origin and 3, minus 4 and 5 as direction ratios of a normal to it. So what is given to us is, we are given our P is equal to 7 units, which is the distance of the plane from the origin. Then we are given direction ratios 3, minus 4, 5 of the normal to the plane. So we can say that our vector D, which is a normal to the plane, can be written as 3 I cap minus 4 j cap plus 5 k cap. So the unit vector D cap will be equal to vector D divided by the magnitude of D. That's equal to, our D vector is 3 I cap minus 4 j cap plus 5 k cap divided by our magnitude of D is equal to square root of 3 squared plus minus 4 squared plus 5 squared, which is equal to square root of 9 plus 16 plus 25, which is equal to square root of 50, which is equal to 5 times root 2. So substituting this value here, you get 5 times root 2, and the equation or the parametric equation form, parametric form of vector equation of the plane is or vector dot product with D cap is equal to P. So we have our P as 7 and we have our D cap as this. So replacing those values, we get or vector dot product with 3 I cap minus 4 j cap plus 5 k cap divided by 5 root 2 is equal to 7. So that's our required answer. Question number 2. Find the direction cosines of the normal to the plane 12x plus 3y minus 4z is equal to 65. Also find the non-parametric form of vector equation of a plane and the length of the perpendicular to the plane from the origin. So we are asked to find 3 things here. 1. Find the direction cosines of the normal. And the second thing that you need to find is the non-parametric form of the vector equation. And the third thing that you need to find is the length of the perpendicular to the plane from the origin. So, given 12x plus 3y minus 4z is equal to 65, which is the Cartesian equation of the plane. Now we can rewrite this as or vector dot product with 12 I cap plus 3 j cap minus 4 k cap divided by the square root of 12 squared plus 3 squared plus minus 4 squared. So that will be 144 plus 9 plus 16 equals 65 divided by root of 144 plus 9 plus 16. So we can further rewrite this as OR vector dot product with 12 I cap plus 3 j cap minus 4 k cap 13 equals 65 by 13, which is equal to 5. So we are asked to find first the direction cosines. Our direction cosines would be 12 over 13, 12 over the root of this, which is 13, comma 3 over 13, comma minus 4 by 13. So that's the first part of the equation. Now for the non-parametric form of the equation, which is the second part of the equation, the non-parametric form of vector equation of a plane can be rewritten using this as OR vector dot product with 12 I cap plus 3 j cap minus 4 k cap divided by 13 is equal to 5. So as this is in the form of OR vector dot product with d cap is equal to 5, our 5 is the distance of the plane from the origin. So the length of the perpendicular to the plane from the origin is 5 units. Question number 3. Find the vector and Cartesian equations of the plane passing through the point with position vector given by this and normal to the vector this. So this is a very straightforward question. So we are given the position vector of the point and we are also given the normal to the vector. So let's use the formula, which is OR vector dot product with the n vector is equal to A vector dot product with n vector. So given to us is vector A is equal to 2 I cap plus 6 j cap plus 3 k cap, and we are also given n, which is the normal to the plane as I cap plus 3 j cap plus 5 k cap. So the vector equation of the plane is OR vector dot product with the n vector is equal to A vector dot product with n vector. So substituting their values, OR vector dot product with the n vector is I cap plus 3 j cap plus 5 k cap, which is equal to 2 I cap plus 6 j cap plus 3 k cap dot product with I cap plus 3 j cap plus 5 k cap. So solving this right hand side of the equation, 2 times 1 is 2 plus 6 times 3 is 18 plus 3 times 5 is 15. So that's equal to 35. So we can rewrite our vector form of the equation as OR vector dot product with I cap plus 3 j cap plus 5k cap is equal to 35. Next, to find the Cartesian equation. The Cartesian equation of the plane, we substituting r cap is equal to xi vector plus yj vector plus zk vector in the above equation. We get xi cap plus yj cap plus zk cap dot product with I cap plus 3j cap plus 5k cap is equal to 35. So further this can be rewritten as x plus 3y plus 5z is equal to 35. So that's our result. Question number 4. A plane passes through the point -1, 1, 2 and the normal to the plane of magnitude 3, root 3 makes equal acute angles with the coordinate axis. Find the equation of the plane. So we are given the point -1, 1 and 2, which is a point on the plane. So our vector A, so given we can say vector A is equal to minus I cap plus j cap plus 2k cap, and we are also given the magnitude of the normal. So magnitude of our normal is 3 root 3. Now it's given that the normal to the plane makes equal acute angles with the coordinate axis, which means the angle that this normal makes with the x, y and z axis are all equal. So our angles will be, alpha will be equal to beta equal to gamma. So, and we know that our direction cosines, using the direction cosines, that cos squared alpha plus cos squared beta plus cos squared gamma is equal to 1, where alpha, beta and gamma are the angles that the normal makes with the coordinate axis. So, but here our alpha is equal to beta and is equal to gamma. So we can say that 3 cos squared alpha is equal to 1, since alpha is equal to beta is equal to gamma. So further we can say that our cos alpha is equal to 1 by square root of 3. So this implies the DC of the normal is 1 by root 3, 1 by root 3, comma 1 by root 3. So our vector n will be equal to, its magnitude is 3 root 3 into 1 by root 3 I cap plus 1 by root 3 j cap plus 1 by root 3 k cap. So simplifying this, this will be 3 I cap plus 3 j cap plus 3 k cap. So we have found the normal, and we also found the vector A, which is the position vector of the point which is on the plane. So the vector equation of the plane can be written as is or vector dot product with n vector is equal to a vector dot product with n vector. So substituting the values, you get or vector dot product with 3 I cap plus 3 j cap plus 3 k cap is equal to vector A is given by minus I cap plus j cap plus 2 k cap dot product with 3 I cap plus 3 j cap plus 3 k cap. This would be minus 3 plus 3 would be 0 plus 6. So it's a 6. Therefore, our vector form of the equation is or dot product with 3i cap plus 3j cap plus 3k cap is equal to 6. Then the Cartesian form of the equation will be of the plane will be substituting let or is equal to xi cap plus y j cap plus z k cap, then replacing xi cap plus y j cap plus z k cap for our vector dot product with 3i cap plus 3j cap plus 3k cap is equal to 6. This would further apply that it's 3x plus 3y plus 3z is equal to 6, which is our Cartesian equation of the plane. Further, we can simplify this as x plus y plus z is equal to 2. Question number 5. Find the intercepts cut off by the plane or dot product with 6i cap plus 4j cap minus 3k cap is equal to 12 on the coordinate axis. So we are asked to find the intercepts cut off by the plane on the coordinate axis, and given to us is this equation of the plane. So let's say given or vector dot product with 6i cap plus 4j cap minus 3k cap is equal to 12. So if we compare this with the form of the equation or dot product with n is equal to q, then we can say that our q is equal to 12 and our n vector is equal to 6i cap plus 4j cap minus 3k cap. So what we can say is let A, B, C be the intercepts of x-axis, y-axis and z-axis respectively. Okay, so then we can say that our q by a, q which is this divided by the intercept will be equal to the number 6 here. Similarly, q by b will be equal to 4 and q by c will be equal to minus 3. So further simplifying each of them, if q by a is equal to 6, then we can say our q is already 12. So 12 by A is equal to 6. This implies A is equal to 12 by 6, which is equal to 2. Similarly, our Q by B is equal to 4. So that is our 12 by B is equal to 4, which means B is equal to 12 by 4, which is equal to 3. Similarly, we can say that Q by C is equal to minus 3, which implies 12 by C is equal to minus 3. C is equal to 12 divided by 3, which is minus 4. So we have our A, B and C. Therefore, the x-intercept is equal to A, which is 2, y-intercept is equal to B, which is 3, and z-intercept is equal to C, which is minus 4. Question number 6, which is the last question in this exercise. If a plane meets the coordinate axis at ABC such that the centroid of the triangle ABC is the point UVW, find the equation of the plane. So we have a plane that meets the coordinate axis at the points A, B and C. So we can define, let A be A, 0, 0 and B 0, B 0 and C be defined as 0, 0, C. In triangle ABC, the centroid is defined as x1, x2, x3 divided by 3. So here will be A plus 0, which will be A by 3, A by 3, similarly B by 3 and C by 3. Our centroid point is defined as U, V and W. Therefore, A by 3 is equal to U, which means our A is equal to 3U. Similarly, you have B by 3, which is equal to V, which implies B is equal to 3V, and C by 3 is equal to W, which implies our C is equal to 3W. The equation of the intercept form of the plane is x by A plus y by B plus z by C is equal to 1. Therefore, replacing the values of A, B and C here, we get x by 3u plus y by 3v plus z by 3w is equal to 1. Further, you can simplify this and say x by u plus y by v plus z by w is equal to 3. So that's the required equation of the plane. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.